So for this tutorial, you'll need a basic understanding of HTML, CSS, JavaScript, and also know your way around the JavaScript console. Snake is a computer game where you are in control of a snake. The goal of the game is to eat as much food as possible while trying to avoid the sides and the snake itself. This project consists of 3 files. One's our HTML file, and the style file, and then the JavaScript file. We'll start off by creating a HTML file. We include the style sheet and the JavaScript file. Now, the game consists of a couple elements. The first one is the game area itself. Inside of that, we'll place a canvas. On top of that is an information overlay with an opaque background color, and also an area to display the score. We'll start off by placing a game area inside of the body tag. We'll give this one a class called game area. I will specify the style for the game area. This specifies the width and the height of the area. Also adds a border. Now if you open the HTML file in a browser, this is what the page should look like. Next, we'll add a canvas into the game area. Now we'll explicitly set the width and the height of the canvas. Now the canvas is styled using its ID. Its width and height is set so that we can fit in a margin between it and the game area. Now the canvas also has a border. The style of the canvas is set so that we can fit in a 25 margin. Opening the HTML file in a browser, you should see this. The inner block is the canvas. I will add a div to contain the score. Now the style of the score is done on its ID. It's placed in the right bottom corner of the game area. Below the score, we'll add the information overlay. Now the information overlay is styled to fill the entire game area. We add a background color with an opacity. Now the HTML file should look like this. Now you can still see the canvas and the score underneath the information overlay. Inside the information overlay, we add some elements to display information. Now these elements are placed inside a div with the class text area. The text area is styled to be in the middle of the information overlay. And we give the heading a font size of 20 pixels and the lines a font size of 15. The HTML file should show the heading and lines in the middle of the information overlay. Now this game has 3 stages. The first one prompts the user to start a game. The second occurs while the user is playing. And the third shows a game over screen, which also displays the score. We'll start off by creating a game object. For now, the only property in it is the score. We'll create a game state object containing the 3 stages, and we'll add the state property to the game object. Now to transition between states, we'll add a function called updateGameState. This function contains code to execute depending on which state the game is in. Now for the game start state, we'll make the information overlay visible, set the text in the heading and the first line. For the game playing state, we'll hide the information overlay. For the game over state, we'll make the information overlay visible, set the heading, the first line, and display the score in the second line. Now to test the stage transitions, you can open the browser console window. We'll set the state to GameState.start and then execute the function updateGameState. Now what you'll see is the text in the information overlay change from the default to the text we set in the game start state. Next, we'll test the playing game state. We'll set the state to GameState.playing and execute the updateGameState function. This should hide the information overlay. Next, we'll test the game over state. We'll set the game state to GameState.gameOver and execute the updateGameState function. This should show game over in the information overlay. Now I'll add some code to execute when the game starts. First we want to initialize the game state to GameState.start and update the game state. Now for the click to start to work, we need to add a click event to the information overlay. Inside this event we'll add a switch statement which tests the game state for GameState.start and GameState.gameOver. This sets the game state to GameState.playing and updates the game state. Now in order for us to draw onto the canvas, we need the canvas context. This is kept as a property inside the game. Now we get the canvas context with the getContext function and we pass in the parameter 2D. Now when working with the canvas, we always want to clear it before we start a new drawing cycle. We'll add the function called clearCanvas. Inside of that, we execute the function clearRect with the size of the canvas. Now the snake game has a playable area of 20 by 20 blocks. Each block has a size of 25 by 25 pixels. Now the canvas has a size of 500 by 500 pixels. By dividing this by 20, we get the block size of 25 pixels. We add the size of the game area and the block size to the game object so that we can use this in code. Now the snake can moving in one of 4 directions. This is called north, east, south and west, and they are mapped to the compass directions. I'll add a snake object to the game properties. It contains a direction and a blocks array. Now the block array contains the position of the snake. In order for us to draw the snake onto the canvas, we'll iterate through each of the blocks inside of the snake and draw a rectangle on the canvas in that position. Now you'll notice that these rectangles are offset and a bit smaller than the block size. This is to add some space between them. Here you can see a comparison with and without these offsets. Going to the browser console window, we can add some blocks to the snake object and then execute the drawSnake function. You should see 2 blocks drawn to the canvas. We'll add a food property to the game object. To draw the food, we'll create a function that draws a red rectangle onto the canvas. This rectangle is also offset and made smaller than the block size. Now back in the console, we can set values for the food property and execute the drawFood function. I'll create a placeFood function. This puts the food in a random position on the game area. Now to prevent the food from being placed on top of the snake, we'll compare the food's position to each of the snake's blocks and set the onSnake property to true if it is on the snake. And if the food is not on the snake, we'll set the game's food property to the random food position. Now in the console, if we execute placeFood and drawFood, you should see the red food block being placed in a random position on the game area. Next, we'll update the score. So we'll create an update score function to set the text inside of the score area. Now when redrawing the snake, its head can go into one of 3 positions. This snake is heading east. Its head can go into the north, east or south position. The way that we'll make the snake move is by adding a new block in its head's direction and removing 1 block from its tail. Depending on the snake's direction, the new block is placed above, to the right, below or to the left of the snake's current position. Now the snake's current position is moved to this new block and will remove a block from the snake's tail. Now to see this movement in action, we can set the snake's position, give it some blocks, and execute the drawSnake function. Call the advancedSnake function, clear the canvas and redraw the snake. Now each time the snake moves, a couple of functions will need to be executed. With the step function in place, We can initialize the snake with some blocks and then call the step function. Each time the step function is called, you should see the snake move. You can change the direction properties value to another direction and then call the step function again. This should make the snake change direction. The step function should be called inside of a timer. This is done with the window.setInterval function. This executes every 200 milliseconds. To test this, we can initialize the snake with some blocks and then call the start game step function. To initialize the game for the playing game state, we'll create a start game function which zeros the score, removes the food, and gives the snake an initial direction. After this, we'll give the snake some initial blocks and set the position of the snake's head. Now at the end of the start game function, we'll call the start game step. Back in the update game state function, we'll add this call to start game inside of the GameState.playing condition. We'll add a pending direction property to the game snake. This holds the next direction of the snake. We'll use the arrow keys on the keyboard to determine the snake direction. To use the keyboard events, we'll add an event listener to the document object inside of the initialize game function. Each direction of the snake has an invalid direction. So here, if the snake is heading south, you are not allowed to turn north. Now the right arrow changes the direction to east. Next, the down arrow changes direction south. The left arrow changes direction west. Now inside of the advanced snake function, we want to apply the pending direction to the snake direction and clear the pending direction property. In the console window, if you execute the start game function, you should see the snake moving and you can control its direction with the keyboard. To detect collisions with the game area border, we should test the snake position and set the game state to game over if the position is outside of the game area. Next, to check collisions with the food object, we'll compare the snake position with the position of the food object. If this matches, we'll increase the score, clear the food object, and duplicate the block at the tail of the snake. To check collisions with the snake, we'll compare the block at the head of the snake with each of the other blocks. If we find a match, we'll set the game state to game over. Inside the step function, after calling the advanced snake function, we'll add the check collision box, check collision snake, and check collision food functions.